Find where the function f of x equal 3x to the fourth minus 4x to the third minus 12x squared plus 5 is increasing and where it's decreasing. Well, the first derivative tells us that information, so let's go ahead and find a derivative. It's going to be 12x to the third minus 12x to the second minus 24x. So let's see about simplifying that. We can take a 12 and an x out, and that's going to be x squared minus x minus 2. And we're interested in where this equals 0 or is undefined, because that would give us our critical points, and it's never undefined, so we're interested in where it equals 0. So we have 12x, this would be x minus 2, and x plus 1. So our critical numbers are going to be 0, 2, and negative 1. So let's go ahead and draw us a number line, and let's put those critical numbers on there. And these are places where the first derivative equals 0. So what I'm going to do is I'm going to test numbers on either side of these critical points and determine if the first derivative is positive or negative, and that will answer my question of whether this function is increasing or decreasing. So let's test negative 2, and the easiest way to test it is to put it in the factored version and just decide if each factor is positive or negative. If I put a negative 2 in here, I get a negative. If I put a negative 2 in here, I get a negative. If I put a negative 2 in here, I get a negative. A negative times a negative is positive, times another negative is negative. So that tells me that the first derivative is negative right here. That tells me the function is decreasing on the interval from negative infinity to negative 1. Now let's test a point in between here. So how about negative 0.5 or negative 1/2? Well, if I put it in this one, it's negative. Put a negative 1/2 in here minus this would be negative. A negative 1/2 in here, this one would be positive because the 1 would be greater. So negative times negative is positive, times positive is positive. So the graph is increasing from negative 1 to 0. Now let's try putting in a 1. Putting a 1 in here is positive. Putting a 1 in here is negative. Putting a 1 in here is positive. So I have a positive times a negative times a positive, which is negative. And so the graph is decreasing on the interval from 0 to 2. And then try putting in a 3. A 3 is positive. 3 minus 2, that's positive. This 3 plus 1 is positive. Everything positive is positive. It will be increasing on the interval from 2 to infinity. So let's go ahead and list this. So we're going to put intervals where it is decreasing, and that would be negative infinity to negative 1, and from 0 to 2. Intervals where it is increasing, that would be from negative 1 to 0, and from 2 to infinity. Now let's see how we did. Here's the graph. Kind of went over the top here a little bit. We'll move it over a little. And we see that we said that it was decreasing from negative infinity to negative 1. There we go, right to this point right here. We said it was decreasing from 0 to 2. Here's 0. And 1, 2. Here's 2. So here's our decreasing segments. Then we said it was increasing from negative 1 to 0. We see that right here. And we say it was increasing from 2 to infinity. Now remember, we're looking at the x values. So here's 2, and we see the graph increases. So here's our intervals of increase, and we saw our intervals of decrease.